Okay, this lesson is circle theorems for GCSE. It's all about various geometrical facts about circles. And here's number one. The angle between a radius and a tangent is always 90 degrees. The radius is the line from the center to the circumference, center to edge. And a tangent is a line that just touches a curve, in this case just touches a circle, at a particular point. So you've got the radius going out to the edge of the circle, the circumference, and then this line, the tangent, just touches the circle at that point. And those two lines meet at 90 degrees. Question 2. The angle at the center is twice the angle at the circumference. Not question 2, example 2. Theorem 2 even. Okay, this is all about having 2 points on the edge, one there, and then you make an angle up to the center from those 2 points, and then from the same 2 points you make another angle up to the far edge, up to the circumference. And this theorem says that the angle at the center is always twice as big as the angle at the circumference. So if the one on the edge is x, the one in the middle will be 2x, twice as big. Looking at this one, well, perhaps it could be that x is 40, and then the angle in the middle is 80. Now that doesn't matter whether it looks like this, for example. You've still got 2 points, and then you're making an angle up to the center, and you're making another angle from the 2 points up to the far edge, up to the circumference. So it could be that it looks like that, and two of the lines sort of line up together. Or it could even be that they cross over like that, but you've still got an angle from 2 points up to the center, and then an angle from the same 2 points up to the far edge, up to the circumference. So the one at the center is always twice as big as the one at the edge in that case. Okay, number 3, angles in the same segment are equal. So if I start with a line, a chord, if I then make an angle from that line, from the 2 ends, up to a point on the edge, up to a point on the circumference, doesn't matter where I put that, those angles I make will always be the same angle if they come from the same 2 points. The segment, by the way, is the part of the circle that we divided the line into. So we drew the line, it divided the circle into 2 segments. So here's an example of that. 48, 50 and x. We've got to find what x is. Now, this angle of 48 came from the same 2 points. You've got a point there and a point there. So the 48 there is the same as the other yellow angle up here, because the yellow angle came from the same 2 points as the 48 came from. So if the yellow angle is 48, and then we can see that we've got a 50 there, that means that x must make that little triangle add up to 180. So that would be 82 to make it add up to 180. Okay, Theorem 4. The angle in a semicircle is always 90 degrees. So it's the same idea as before, with having 2 points on the edge of the circle and then making an angle up to the circumference of the circle. But this is a specific case of that. If the 2 points happen to form the diameter of the circle, so that it splits it into 2 semicircles, then the angle you get on the edge is 90 degrees. Doesn't matter where you put it, it's always going to be 90 degrees. Okay, number 5. The opposite angles in a cyclic quadrilateral always add up to 180 degrees. Quadrilateral is a four-sided shape, and a cyclic quadrilateral is a four-sided shape where all the corners, all the vertices, to use the proper word, lie on the edge of a circle. So this is a cyclic quadrilateral here because the 4 points A, B, C and D are all on the edge of a circle. And the property that cyclic quadrilaterals have is that opposite angles add up to 180. So for example, A plus C is 180, the two red ones, and the two yellow ones, B plus D, makes 180. So if A is 125, C must be 55, so that they add up to 180. If B is 72, then D must be 108, so that they add up to 180. Now here's an exam question that's often thrown in to trick people. This looks a bit like a cyclic quadrilateral, but it's not, because only 3 of the corners, the vertices, are on the circumference of the circle. The angle X, that's not on the edge of the circle, it's at the middle, so that's not a cyclic quadrilateral. And in fact, the way you do this one, you need to think back to the other theory about the angle at the center being twice the angle at the circumference, because you've got 2 points there, and then they make an angle at the circumference of 108, so they must make an angle at the center on the other side of 216. The angle at the center, 216, is twice the angle at the circumference, 108, because they both come from the same point. It's a bit of a tricky example, that one, because it doesn't look like the diagram or the diagrams that we saw in the previous examples, but it is that theorem. The angle at the center is twice the angle at the circumference. So if that's 216 in the middle, then X that we're looking for is 164, so that the middle adds up to 360. Okay, number 6. The angle between a circle and a tangent is equal to the angle in the alternate segment. This is the hardest of the theories. It's, I reckon, the hardest diagram to recognize. But you start off with a circle, and then a tangent to that circle. From that tangent, you draw a chord. So one end of the chord is just touching the tangent where it meets the circle. From that chord, you draw 2 lines to make an angle up to another point. And that angle is the angle in the alternate segment. The chord divided the circle into 2 segments, and that segment is called the alternate segment. So the angle in the alternate segment is equal to the angle between the tangent and the chord. Well, it's the 2 yellow ones that I've shown there are equal to each other. So there were quite a lot of steps to that, so you have to remember tangent, chord, angle, and then what's equal. So that's why I reckon it's the hardest one to recognize. Number 7. The lengths from where 2 tangents touch a circle to where they meet each other are equal. So you've got 2 tangents to the circle meeting up at some point outside the circle, and the 2 red lines there are the same length. That's all that's saying. Okay, well that's it. So go away and practice some questions.